Welcome students. Today in this session I am going to discuss on the topic physical properties of liquids. Before that, what is liquid state? It is a state of matter in which intermolecular forces are strong. Then what are the characteristics of liquids? The liquids have definite volume. Shape of liquids are not definite. Liquids are much less compressible than gases. Liquids diffuse like gases, but diffusion is smaller. Coming back to physical properties of liquids. Liquids exhibit certain physical properties which are characteristics of each liquid. For example, the intermolecular attractive forces present in a liquid impose some kind of resistance to flow which varies from liquid to liquid. This property is known as viscosity. Another important property is that it has a surface which limits the amount of space that it can occupy, and it is surface tension. Both surface tension and viscosity are briefly discussed in today's session. First, we discuss about surface tension. Surface tension is a property related to intermolecular attractive forces within a liquid. Consider a molecule. Situated in the interior of a liquid, this molecule feels no resultant attractive forces on it because it is uniformly attracted by other molecules from all sides. But when we consider a molecule at surface, this is not the case. It was attracted by molecules below it and at the sides. In other words, the molecules at the surface are pulled downward and sideways by other molecules, but not upward. Due to this inward pull at surface molecules, the liquid surface behaves like a stretched elastic film or membrane. This property is referred to as surface tension. Thus, the surface tension of a liquid is defined as the force acting at right angles to any line of unit length along the surface of the liquid. And its unit is newtons per meter in SI system, and in the CGS system the unit is dynes per centimeter. It is normally denoted by gamma. Surface tension is always reduce the surface area to a minimum. Suppose if we want to increase the surface area, a work to be done against the force of surface tension and requires expenditure of energy. This energy is known as surface energy. That means the work or energy required to increase the surface area of a liquid by 1 unit. Its unit is joules per meter square in SI system and ergs per centimeter square in the CGS system. Next, I am going to discuss different factors that affecting surface tension. First factor is temperature. As the temperature increases, the kinetic energy of the molecules increases and thereby intermolecular attraction decreases. Hence, surface tension decreases. The temperature at which the surface tension of the liquid becomes 0 is called the critical temperature of that liquid. The effect of temperature on surface tension of a liquid is given by Ramsay-Shield equation. And this equation is given as gamma into m by rho all raised to 2 by 3 equal to k into Tc minus T minus 6, where gamma is the surface tension at Kelvin temperature T, T is the critical temperature, m is the molecular mass, rho is the density of liquid, and K is a constant. The second factor that affecting surface tension is impurities. The presence of impurities affects the surface tension depending on the solubility of impurities. If the impurities are soluble, then the surface tension may increase or decrease. The surface tension of liquid will decrease when the impurities are less soluble. For example, camphor is less soluble in water, hence it decreases the surface tension of water. On the other hand, the surface tension of liquid will increases when the impurities are more soluble. For example, the salt is more soluble in water, hence it increases the surface tension of water. While the insoluble impurities such as dirt, oil, grease, etc. will decrease the surface tension of a liquid. The third factor is nature of liquids. Surface tension of a liquid depends on intermolecular forces present in that molecule in such a way that greater the intermolecular attractive forces, greater will be the surface tension. For example, the intermolecular hydrogen bonding in water is considerably greater than ethanol. Thus, the surface tension of water is much higher than that of ethanol. The fourth factor is density. Higher the density, greater the surface tension. Now, let's see how the surface tension of a liquid can be determined. By experimentally, the surface tension can be measured by using stalagmometer. Stalagmometer is a glass tube widened in the middle part. Its volume is calibrated by the scale shown on the tube or by the top and bottom lines. The bottom part of stalagmometer is modified such that the liquid flowing through its smaller diameter and forms drops. The drop of a mass m gets released when its weight mg is equal or greater than the surface force at the end of the tube. The weight of the drop mg is equal to 2 pi r gamma. This equation suggests that from the known value of mass of water and radius of stalagmometer tube, the surface tension gamma can be calculated. But the problem is that only 2/3 of the drop volume gets released. On the other hand, the ratio of mass and surface tension is constant for all the liquids. Let's consider two solutions with mass m1 and m2 with its surface tension gamma 1 and gamma 2 respectively. Then the relation is given as m1 by m2 equal to gamma 1 by gamma 2. If the liquid with non-surface tension is used for one of them, usually water, the surface tension of the other liquid can be calculated from the equation. Gamma is equal to gamma of water into m by m of water. During this stalagmometer method, we have to some precautions to be taken, otherwise lead to error. First precaution is tip of the instrument should have no imperfections in the outer circumference. Drops should be formed slowly. About 20 to 30 drops should be collected to find the average weight. Temperature should be maintained constant. By this discussion on first physical property of liquid, surface tension is over. Next property is viscosity. You have already studied in your lower classes about viscosity as it is a resistance to the flow of liquid, right? But some liquids like water, kerosene, etc. show good flowing property, but honey and castor oil can flow easily. Then what is the reason? This is due to the internal friction between layers of a liquid as they slip past one another while the liquid flows. Obviously, this internal friction varies from liquid to liquid. Liquids which offer less resistance to flow are said to be less viscous, and which offer greater resistance are said to be more viscous. Let us visualize a liquid moving in a tube and consider the laminar or streamline flow of layers of the liquid in which adjacent layers of molecules move at different rates. A thin layer immediately in contact with the wall of the tube remains almost stationary. The velocity of the successive layers from the wall increases and remains maximum for the central layer. Therefore, there is a velocity gradient, that is dV by dx of the flowing liquid. Here, each layer experiences a frictional force which is known as viscous drag from the adjacent slow moving layer. Thus, this retarding influence of slower moving layer on the adjacent faster moving layer is responsible for resistance or viscosity. Now we are going to discuss about coefficient of viscosity. Simply, it is a parameter by which we can express the viscosity of a liquid. To understand in detail, consider any two parallel liquid layers of area A separated by a distance dz. The velocity gradient between two layers will be du by dz. To maintain the flow against the viscous force, a force F is required which is directly proportional to the area in contact and the velocity gradient. That is, F is proportional to A and F is proportional to du by dz. So, combining these two equations, we got F is proportional to A into du by dz. To change this proportionality sign, we multiply this by a constant, so that equation becomes F equal to eta into A into du by dz. This proportionality constant eta is known as coefficient of viscosity. According to the above mathematical formula, viscosity is defined as the force per unit area originated between the two layers moving with the unit velocity gradient. The unit of viscosity coefficient eta in CGS system is Poise, that is gram per centimeter inverse second inverse. In SI system, the unit of eta is Pascal second, that is kilogram meter inverse second inverse. Coefficient of viscosity is related to fluidity. Fluidity is the reciprocal of viscosity, which is a measure of the ease with which a liquid can flow. That is, fluidity phi is equal to 1 by eta. Also, if the intermolecular attractive forces within a liquid is greater, the greater the resistance to flow and the greater the viscosity. Then, what are the factors that affecting viscosity? First one is increase of temperature decreases the viscosity of liquid. Second one is presence of other substances such as colloidal matter increases viscosity. Third one is, in the case of a homologous series, viscosity increases as the molecular mass increases. Fourth one is, viscosity increases as the branching of the alkyl chain increases. And the last one is, viscosity increases due to the intermolecular hydrogen bonding increases. Now let's see the reason behind the increasing nature of viscosity with decreasing temperature. As the temperature increases, the molecules get greater kinetic energy and sufficient to overcome intermolecular attractive forces. As a result, one liquid layer is able to slip past another with more ease. That means viscosity of a liquid decreases with increase in temperature. The scientist Arrhenius gives the mathematical relation between temperature and viscosity. The equation is given as eta is equal to A e raised to E by RT, where A and E are constants characteristics of liquid. T is Kelvin temperature and R is the universal gas constant. E is in fact called the activation energy for the viscous flow. When writing the above equation in logarithmic form, the equation changes to log eta equal to log A plus E divided by 2.303 RT. This is a straight line equation. So, on plotting log eta against 1 by T will give a straight line in most of the liquids with slope E divided by 2.303 RT. Suppose if we measure the viscosity of a liquid at two different temperatures, T1 and T2, then these viscosities are related to each other by log eta 1 by eta 2 equal to E by 2.303 R into T2 minus T1 divided by T1 T2. By this equation, we can calculate the activation energy for viscous flow of a liquid. Next, we will discuss different types of viscosity. There are two types of viscosity: dynamic viscosity and kinematic viscosity. In dynamic viscosity, viscosity of liquid is studied with respect to force. Its unit is Newton second per meter square. While in kinematic viscosity, viscosity is studied with respect to motion of fluid and its unit is Stoke. So far, we have discussed the viscosity, coefficient of viscosity, effect of temperature on it, and different types of viscosity. But it was necessary to measure viscosity in order to understand above factors. Then, how it can be measured? Viscosity can be measured using the Ostwald's viscometer method. This method is based on Poiseuille's equation. Poiseuille's equation gives the coefficient of viscosity as eta equal to pi p r raised to 4 T divided by 8 into V into L. Here, V is the volume of the liquid flowing out of the tube. T is the time taken for liquid to flow. R is the radius of the tube. L is the length of the tube. And P is the driving pressure needed for uniform rate of flow of volume V of the liquid. Then coming to Ostwald's viscometer method. The important part of this method is Ostwald's viscometer, which is a U-tube with a bulb on either arm. The lower part of bulb A is attached to a fine capillary tube B, which in turn has its lower part attached to the remaining wider portion of the apparatus containing bulb C. The instrument must first be calibrated with materials of non-viscosity such as pure water. In an Ostwald's viscometer, a fixed volume of liquid is allowed to fall under its own weight and the time required for flow is noted. In such an experiment, the driving pressure P is equal to H into D into G. Here H is the length of the tube, D is the density and G is the acceleration due to gravity. Substituting the equation of P in Poiseuille's equation, then Poiseuille's equation changes to eta equal to pi h d g r raised to 4 into T divided by 8VL. Suppose equal volumes of two liquids 1 and 2 having densities D1 and D2 are allowed to flow through the same tube under the identical conditions of temperature and pressure, then the coefficient of viscosity eta 1 and eta 2 respectively are given by eta 1 equal to pi h d1 g r raised to 4 T1 divided by 8VL and eta 2 equal to pi h d2 g r raised to 4 T2 all divided by 8VL. So, combining these two equations and cancel the common terms, we got eta 1 divided by eta 2 equal to d1 T1 divided by d2 T2. By using the above equation, we can calculate the coefficient of viscosity of one liquid by knowing the viscosity of other liquid densities D1 and D2. Usually, water is taken as the non-liquid. Then, eta 1 equal to D1 T1 eta 2 divided by D2 T2. Viscosity has so many applications in our daily life. One important application in human body is that blood circulation through arteries and veins depends upon the viscosity of fluids. Increased viscosity increases the resistance to blood and thereby increases the work of the heart and impairs organ perfusion. So, with this, I am concluding this session. Thus, today we have discussed the physical properties of liquids such as surface tension and viscosity. Also discussed the different methods by which these properties are determined. Hope the discussion on physical properties of liquids is clear to you. Thank you.